All right, guys, welcome back to our security video. My name is Ngane Emmanuel. I'm a software engineer. If you're watching this series, you're watching part of a series titled Building Secure, Scalable, Fault Tolerance, and Low Latency APIs with Spring Boot and Java. So in the last video, we talked about, we introduced authentication, and today I just wanted to reiterate about security, right, and how requests flow. So let's talk about what authentication really means. And today it's also a very interesting lesson. I hope you pay attention to the end. Like and share this video. Subscribe to the channel and click the notification bell. The resources and relevant links are in the comments in the description below. And comment your questions and I'll get to you as soon as I can. All right, let's dive right in. So in this video, we are going to talk about something most developers think they understand, that's authentication, but usually they do understand only in the surface level. See, for many people, authentication just means user login, get a token, and that's it. But a real system, especially in production system, which is what we are doing, authentication is not just login, right? It's not a login feature. It is an end-to-end system security process that starts from the moment a request leaves the client and ends when the response gets back. So today we are going to be looking at, as you can see up on the screen, we have the infographic and the entire pipeline that I developed. And so we're going to be talking about it in general. And after this, we're going to have a video to talk about each stages. So let's look at the big picture, which we have up on the screen. So when a client sends a request, as you can see, to the back end, it does not go directly to the controller, because as you can see, this is where your controller is, right? It doesn't go directly to your controller. So it passes through many layers, right? Each of these layers have a different responsibility, different risks that are associated with them, and different security controls that you have to implement. If you only secure one layer, your application is weak. Real security comes from layering, okay? So you have to secure all the layers, and this is called defense in depth. So let's look at stage one, the client. So this could be a mobile application, a web application, Postman, or even an attacker script, right? So at this stage, your backend has nothing yet. The request only exists only on your machine. The client builds something like, I want to send this particular request with these headers, with this token, and with this body to this particular endpoint. And in this stage, like I've been mentioning, the first rule you have to keep in mind in this stage is that you trust nothing. Even your own front end, you trust it, because everything can be modified, everything can be faked, okay? So everything can be changed. So at this stage, security is mostly about using HTTPS for securing data in transit, protecting token to avoid token reusable tokens, preventing token leakage, right, and preventing cross-site request forgery, right? So, but the back end again has not yet started protecting itself yet. So let's move to stage two, which is network and server entry. And so this is stage two. So at this stage, it passes through routers. So your request passes through routers, networks, and possibly reverse proxies. Okay. If you're using something like Cloudflare, Nginx, and AWS load balancer, this is where they operate. At this stage, the Spring Boot app is still not running again, but attacks can happen. So, for example, we have WAF attacks. So web application firewall. So so web application firewall is going to protect against distributed denial of service attack. So port scanning attack can occur here. Traffic flooding can also occur here. So defenses that will also be present here will include firewalls, again, web application firewalls, like I talked about, WAFs, IP filtering, of course, and infrastructure rate limiting to limit resources. And then now at this stage, that's your external shield. And now we move to the servlet containers, which is now your Tomcat. Okay. Now the request finally enters your Java application and it hits Tomcat servers. So at this point, Spring is not handling it yet. So we are looking at Spring Boot here. So this is the instance of Spring Boot, but from year to year, right? It's general. But at this stage, then we look at Spring Boot. So this will basically be your server, and this will be your entry point of your server. In this case, this is Spring Boot, and it's going to hit the Tomcat servers. Okay, and at this point, Spring is not handling it yet, and controllers are not involved. No beans have been injected. So Tomcat assigns the thread and wrap the request for this particular stage. And then, because attackers can, try to exhaust your thread, defense at this level is mostly about thread limiting, connection limits, and timeout. Okay, so if all threads are busy, your app is definitely down. So you have to protect against that. Yeah. And then the next stage, again, is called filters. We're looking at the filter stage. And at this stage, now we reach the first really important application layer. And this is where we'll start our next videos from the filter stage. And this is where we are going to be focusing most of our effort, because again, this is where application protection kind of makes sense. I think where you mostly have most of the control when you're developing an application in Spring Boot. And what you would, so yeah, this is before the Spring MVC, so before controllers, before request mapping. So at this stage, there is no controller that is being loaded, no services called, no business logic exists. So it makes filters perfect for early security, and that is why, because this sits below and comes early. So this is where you usually do your calls, your rate limiting, your authentication, your request validation, and login for audits, right? So why here? Again, you're going to ask the question, why do you do all of this here? Again, like I said, because if a request is malicious, you want to kill it as early as possible. So you don't want it to use load services or use resources not after opening database connection before you go, hey, this request is bad, let me terminate it. So you want to get it as early as possible, and this sits low on the request chain, and you see it is just after the Tomcat server, and it is before the Spring security and before interceptors and controller validations. So you can, this is very nice and very convenient, and production advisable, I don't think that's a word, but recommended to put your validations, your authentication, sorry, your calls, your rate limiting, and request validations and login here, right? So yeah, when you do it there, the save resources. So let's move to the next, which is stage 5, which is Spring Security Filter Chain. Okay, inside your filter layer, right, the Spring Security runs. So when you have in your filter layer the Spring Security, this is where authentication is really happening. And the framework extracts the token, it validates the signatures, and it checks expiration dates, and then it loads the user, okay, and creates an authentication object, and then that gets stored in a security context. So all of that happens in your Spring Security Filter chain, and after this step, Spring knows who is making the request, and now you can access security context holder. Okay, so when you access security context holder to get, I think, the authenticated user, and so that all of that happens here. If this step is weak, your whole system is compromised, and so this layer must be extremely solid. So let's go to stage 6, which is interceptors. So after authentication, we wish the interceptor, and interceptors run after the user is known. So again, we have the authenticated user has been loaded in the security context, and now we know the authenticated user, and we can use it within the interceptors to check for authorization. And interceptors sit before controllers execute, right? So this is where you can implement custom authorization, ownership checks, and for those of you who don't know, ownership checks, that's verifying that the user request an action is a creator, right? Is that of the creators. So for example, the designated owner of the resource is trying to access a particular resource. You have to verify that the resource that a particular user is trying to access belongs to that particular user. And this is also where you do your audit logs, right? And what are audit logs? Again, these are immutable records that document all significant activities in your API usage and management. Okay. So, for example, if a user is allowed to access this resource, so you're checking if a user is allowed to access this resource, and not just that the user has authority or has the role of admin or has a particular role that permits it to access the resource, right? So you don't just check for role permissions, you also check for ownership permissions, because again, it all depends on your design, your system design, right? And this particular place is where a lot of systems fail because they only check for roles but not ownership. So you can look into that. And if you also check, I think if you also check just for role and not ownership, that can lead to insecure direct object reference, which is basically using user supplied inputs to directly access data records or files or user account without validating them. So we spoke about that in our previous security videos. We also talk about validating all user inputs. So verification of ownership also helps to prevent IDOR, which is IDOR, insecure direct object reference. So let's go to stage 7, which is dispatcher servlet. Okay, and this is just before we enter the controller, although I kind of miss it. But this is part of the controller level, but you get why I put it at stage 7 and I put controller here and I'm talking at stage 7. But it's called dispatcher servlet, and this works with the controller. And basically, in Spring Traffic Controller, right, the dispatcher servlet decides which controller, which method, and which arguments. Okay, it also applies the validation and conversion. So if mappings, if it also it makes sure it applies mappings from the request to the respective objects, which we have seen in our controllers that we created in the last couple of videos. So if mappings are wrong, your security can be bypassed, as we also saw in our security and in our security videos and practical sessions. So proper configurations here matter in the dispatcher servlet, which definitely flows now to stage 8, which basically they are one thing. This is controllers, and now we finally reach the controller level. At this point, the user is authenticated, authorization has been run, validation is applied. Okay, so we apply validations, additional validations at the controller level, as we have seen in our previous videos. And so yeah, so this is where all of that sits in, and you have to make sure that your controllers are thin. Again, I spoke about this. You don't want to have business logic in your controller. Okay, they should accept DTOs. We saw that, which protect against mass assignments. They should validate input. Again, we saw that, which protect against injections and IDORs. They should also call services, not direct repository, so that you can have further validation and authentication conducted within the service layer, right? That said, let's go to stage 9, which is our service layer. And the service layer is where real security continues, right? So security continues here, and this is where the business rules live and the transactions are run. Ownership is enforced here. Of course, calculations happen, right? So many attacks and issues kind of occur here, and so you have to be careful when implementing and designing your security, your service layers. So you want to make sure to avoid certain errors that can lead to, for example, like if if you are conducting transactions, you want to make a design to avoid double refunds or negative balance or race conditions, right? So security in this layer mostly focus on implementing or enforcing the ASIC behavior, right? That is atomicity, consistency, isolation, and durability. Again, if you don't know what these are, atomicity, I think, deals with making sure that all operations in the method run or none run at all. Consistency makes sure that the database move from one safe state to another. Isolation, I think it has to do with how concurrent threads or access, that particular process, and durability of that data, and durability talks about, I think, making sure that if a commit happens, it cannot be reversed. So a commit is permanent. I think so. Yeah, that should be it. So you can enforce that, just a side note, using transactional, which we are going to see. Hopefully, I think, yeah, we're going to see transactional in our Spring Boot practical session if we have not already seen it. Again, consistency happens here and server-side validation in the business logic, right? And now we move to the final layer, which is the database layer, data access. And so at this stage, all previous layer worked and only a valid request arrive here. So in this case, we are more concerned about, in this case, we are more concerned about prepared statement, using a prepared statement and limit data permission. So you want to go with least privilege design pattern here. So your application should have just the privilege that you are talking about, you want it to have. For example, if you're designing a microservice and you're currently working on a search service, a search service doesn't need to have a read permission. So you have, so when creating a user for that particular service, you have to design a search service doesn't have to have a write permission, right? Or an update. Is it an update? Yes, an update permission or something like that. Basically, it only has to have like a read permission, and also the read permission has to be limited to certain tables, so you should not be able to read every other table. And so you have to give it just the least permission, so the least privileges, and that should be okay. So you want to reduce privileges for your application, and you want to make sure that you encrypt data using database encryption. You can use the database encryption mechanisms to encrypt the data, and you want to optimize for speed and by using primarily proper indexes. Okay, so I think that is it. So you have HTTPS, rate limiting, auth and authorization, validation, and security logic. Then you have the database layer. So again, after this, I think you are going to have now the response flow, which basically is you responding to the client. And for response, again, it's something that you have to take note of. You want to make sure to remove sensitive fields in your response, so things like passwords, tokens, and other maybe extra data that is not being requested. You want to prevent that. Again, using of DTOs can help you remove some of this data. And also you have to manually check and validate. So basically you validate when you're sending a request and you're validating the response to make sure that your response meets the requirements. Okay. You want to also add security headers in your response and log important events. Again, this is for auditing, to be able to know what happens within your system. So you never want to leak password, tokens, and internal error messages. Again, we spoke about it, we've been talking about error messages. So you never want to leak internal error messages. Okay. So that said, I hope this makes you understand what authentication really means. So let's recap this. So authentication does not mean user login. It means, right, every layer of your system continuously verifies and enforces identity and permission. Okay, so when you think about authentication, it is asking a series of questions. So basically, you have authentication or authorization. Those are terms on their own, which one can means asking who are you, and the other what are you allowed to do. But the entire process of authentication itself, which includes usually they call it auth, which include authentication and authorization, it is not just logging in a user or verifying a user. It also goes beyond it verifies the source of the request, and a lot of other things, which we are going to see gradually. You are going to look at course, we are going to look at rate limiting, IP addresses, blacklisting, and set a lot of other things, which is all part of the authentication process. And in this case, we are authenticating the request, the inputs, the data, that's the data itself, and the users that are sending the request. So it's an entire system, all right? Every layer of your system continuously verifies and enforces identity and permissions, okay? So from network to filters to service to databases, you have to implement security everywhere. So let's see, what did I forget something? Right, so I think that should be it. So you should definitely take into account all of this. Yeah, so that's basically it for this particular video, and it was not meant to be a long video. It's for me to just walk you through to the big picture of the entire thing. And from next class, these are all going to be practical sessions. Right? We're going to talk about the filters. We're going to see practical implementation, which I've already implemented. You're going to see how they work, what you can implement. You're going to see implementation of course. You're going to see implementation of rate limiting. We are going to be using Postman, so you will not see a call, although maybe I will just create a basic front end to send a request, maybe a React. That could make sense. You can also see like a rate limiting here. We are going to implement rate limiting. We're going to see this in Postman, and this is going to work with the security filter chain, the Spring security. Basically, we're going to register the filters in Spring, and authentication is going to work here. We're also going to look at interceptors for roles and controllers. So that said, I hope that this video was really good. I hope that you understood everything we have talked about here. I hope that you're taking this series seriously, and if you have questions, please leave them in the comment below. I'll be happy to respond to you as frequently as I can. And that will be all for today, and see you in the next video where we are going to talk about filters. Thank you all for watching, and have a nice day.